As we move into the first general category of reactions, ionic reactions, we need a little more background. Now you know that atoms go together to make ions, and ions can come together to make charge-neutral ionic molecules. But what you now need to know is if those ionic molecules are mixed in water, it can revert back to the ions. And those ions help water conduct electricity. And hence, ions dissolved in water are known as electrolytes. Now, you might have heard the term electrolyte from Gatorade, which puts electrolytes, certain electrolytes, sodium electrolytes, potassium, and chloride back into the body. When you sweat, you lose those. They're necessary for function under stressful conditions, and Gatorade is meant to replenish those electrolytes. So let's look at a quick example of what we mean when we say it conducts electricity. That's meant to be taken literally. If you take pure water and you hook a battery up to it, and a voltmeter, you'll see the voltage is zero. And what that means is pure water, despite what you've ever heard, is a poor conductor of electricity. So if we now add to our pure water sodium chloride, it will break apart into sodium ions and chloride ions. And what we will find out is the voltage goes from 0 to whatever the voltage of the battery is. In other words, the sodium chloride molecules will break apart into ions, and that will allow it to conduct electricity. Hence, sodium chloride produces electrolytes. As an aside, you might have heard of this process called electrolysis, and that is essentially where you're actually pumping electricity in a solution to force molecules to be broken down into ions. And with that as a background, let's move to our first general category of reactions, ionic reactions, and in particular, double displacement.